Good afternoon, everyone. So I'm Adrian Tolentino from Analog Devices. So I'm the manager of BMS Systems and Applications Engineering in ADI. And my presentation is on earlier development, faster time to market, and more sustainable EVs or electrical vehicles through battery management system emulation. So it's a bit wordy, so please bear with me. Okay, so this is the presentation outline that I have. So what we want to answer is ADI is a semiconductor company, but why are we making or why are we doing emulation? So we can tackle that in 4 points. First is we need to establish that ADI now is moving up the stack or the value stack, and then I'll give an introduction of what the ADI's BMS emulation is. And then I'll go through the benefits that the customers see on the emulators, and then we'll have a showcase or a touch base on the R&D in ADI. So what does moving up the stack or the value stack for ADI mean? So as a company, ADI's purpose is to enrich people's lives through signal processing technologies and transforms people's experience with technology by bridging the analog and the digital world. So we are able to drive that purpose by building the solution stacks. Okay, but since ADI is a semiconductor company, and in order to be able to create solution stacks, we need to develop on the technology or the core technologies that ADI has, and we start that with creating the embedded technologies, digital and software. On top of that, moving up to the solution stack. Okay, so how does ADI do that? So I'm going to show you an example of how we do this on the automotive side. So this is an example of the emerged technology that ADI has pursued. This is the wireless battery management system. So traditionally, we know battery management system to be a wired system, but ADI has ICs or integrated circuit products for this. Basically, in order to create the wireless battery management system, we need the RF transceivers and then the battery management system products itself. But as ADI moves up the stack and bring more value to the customer, we need to develop modules, or for this case, we have the ADI BMS eval kits. And then moving up the stack, we need to support the customer's needs in order to be able to give them the measurements, analytics, and ultimately the service of the service for the wireless battery management system. So moving forward, as I've said, with just the ICs that ADI is able to give, we are limited to the value that we can give to customer. But as we move up the stack, we are able to give value beyond the silicon. So because we have the whole system solution, we are able to provide value in manufacturing, life cycle monitoring, flexibility and user experience, and on the second life for our electric vehicle batteries. So now, I'm not here to talk about wireless battery management system, but I'm here to talk about something that's on the embedded layer, or something that's above the core technology layer of ADI, which is the battery or the BMS emulation. So for the customers actually need to learn features of the battery management systems that we offer immediately. And then there's a need for them to start software development with or without the actual BMS ICs. And then there's also a thrust for innovation on their side, on the battery itself and the battery management system that they are developing for their specific products. And then they need to develop and validate the functional safety concepts that they develop. So in the center, we are showing you the customer development phases wherein we're able to bridge to the needs of the customer. So this is early software integration and testing, HIL or hardware-in-loop BMS controller validation, fault injection, and FuSa or functional safety testing. full battery stack validation, complete BMS family testing, and then lastly on the model verification. And that brings us to the end of life testing. So as I've said, with just the ICs, we can only bring them to the Hill BMS controller validation. But because we're moving up the stack, we're also able to give value through model verification. And this allows the customer to customers to innovate their own battery management systems. So what is ADI BMS emulation? So let's start first with the traditional concept of validating or evaluating their own BMS. So when they do this, they have a setup for a conventional rack for Hill test solution, and they integrate that to their own battery management system. So for example, if the customer chooses us for their solutions, there goes our ADI BMS eval boards. So this means that we need the actual hardware integrated into this bulky and expensive test rack. And this is actually an overkill and inconvenient for them, especially on the earlier developments. So what we wanted to do is to emulate all of that. Just have that big Hill or HIL test rack and the BMS itself in just one module, okay? And this allows us to actually simulate the whole battery pack together with the BMS solution. This means that with the BMS solution or the emulator, we're emulating the whole battery pack and the eval board for the customer. We're able to inject a lot of use cases for this one. So for example, this one, we're able to detect electrical measurements or even faults. The faults that we're able to detect, for example, is the battery shortage. And then we're also able to detect high current faults. And then there's also the use case of over temperature, which actually, as in the earlier presentations, this is the killer for the battery management systems. And we're also able to inject under temperature faults. There's also the case of isolation resistance simulation and eventually the fault testing for that one as well. And then there's also the open wire detection and open wire fault analysis. So basically, all of this is, we're able to do all of this with just the emulator itself, without using an actual battery pack, without using an actual conventional hardware-in-loop test rack, or even without the actual BMS hardware. Okay, so moving forward, the key features of the value that we are able to bring in for the BMS emulation is that it's portable alternative to the Hill racks. It's available months before the actual first release of our BMS products, specific for a customer. And then it can emulate the whole BMS pack. So you just need one device in order to emulate a device that consists of 22 BMS ICs daisy chained together. It also implements all positive and negative fault injections. And then it's field updatable, so meaning you can actually program it on the test use case that you want to do. And then it supports our proprietary ISO SPI and SPI connection so that customers can use whatever they need to use. So basically, that's basically the BMS emulation development that we're doing. Just to close that discussion, the BMS emulation is actually an ongoing development. We basically just get the requirements for a customer, develop that, and give them also feedback to them what ideas we have in order to develop the solution further. And then that cycle goes on. And it's actually the same on all the other application focus of ADI. So we have application focus on digital factories, automotive, digital healthcare, immersive consumer, 5G, next-gen connectivity, and autonomous transportation. So lastly, these are the latest developments of ADI on the high-speed signal processing platform. There's also the ORAN, compliant radio unit platform. So ADI started from just the ICs, and then we're already moving up to platforms. And hopefully, eventually, we reach to the level that we're able to deliver services for our customers. So that's all. Thank you.
Any questions on the floor? Okay, we have Sir Chicho. I think there's a microphone in the middle.
No, I'm just curious, no, with the battery management systems. Are there actually activities going on here in the Philippines that require that kind of technology?
The quality, we haven't actually reached out to any customers here in the Philippines yet. But with the battery management or the EV development, I believe there's charge as well, and there are other efforts that is tied with the university.
Okay. Yeah, thank you.
Okay, thank you.
Thank you, Sir Chicho. Another question from the floor?
So about the BMS emulator, do you use the for the emulator? Are you emulating the battery or just the BMS? Because
Yes, the emulation actually includes a model of the battery inside as well. So because of that, we're able to simulate use cases for example, unbalanced cell battery voltages, and customers or even internal in ADI, we can explore different how should I say this, different approaches to balancing the battery packs using our products.
So is the battery just certain models, or are you trying?
That's something that we can't disclose yet, but basically it's a platform wherein we can develop our own battery models as well.
Thank you.
So, Engineer Adrian, is the BMS ECU, is it only for analog devices, or is it like available for use for like universities or other
Okay,
organizations?
Currently, the emulation or the emulator platform itself is being marketed to our customers, but I think that's going to be a discussion with the marketing people. But if there is interest in the university or other institutions here about the emulation that ADI is doing, you can actually contact us for it.
Okay, thank you. So, we'd like to award this certificate of appreciation to Engineer Adrian Tolentino for sharing their invaluable insight and work on earlier development, faster time to market, and more sustainable EVs through battery management system emulation during the NISCON 2024, given this 19th of July 2024 at Novotel, Quezon City, Philippines, signed by our director, Lou Andrew Tria.